Hello, this is the second of two videos on the subject of two key formulas of probability theory. In our last video, we defined some terms like sample space and showed how to represent this in a diagram. We defined partition, which consists of sets or events that are disjoint and whose union is the entire sample space. We define the probability of an event, and we gave this formula for the probability of an event in terms of conditional probabilities of that event on each set in the partition times the probability of each set in the partition. In fact, this can be written in summation notation as the sum from n equals 1 up to large N of the probability of B given A N times the probability of A N. And that's a shorter way to write the same formula. Right? We gave some examples of students. So here you see the event B, you see the partition A1, A2, A3. And we can find the probability of B in terms of the probabilities of B conditioned on each set in the partition. So we saw that. And we have two exercises for you to do. So that was last time. Now in this video, instead of expressing probabilities in terms of conditional probabilities, we are going to be expressing expected values or expectations in terms of conditional expectations. Now, what is an expectation or expected value? The expected value of a discrete random variable is defined as follows. The expectation of x is equal to the sum from k equals 1 to capital K of small x sub k times the probability that x equals small x sub k, where small x sub 1 up to small x of big K are the possible values obtained by the random variable x. Let's look at these terms. First of all, we have random variable. What is a random variable? A random variable is a variable whose value depends on the outcome of a particular experiment. For example, you can think of throwing one dice, and then the random variable would be the outcome. Then my set of x1 up to xk would be the possible outcomes, which are 1, 2, 3, 4, 5 up to 6. And the probability of each outcome is 1/6 in this case. Now in this case, if I wanted to compute the expected value of this random variable, I would simply take the sum over these 6 possible outcomes times their probabilities. So if I wanted the expected value of x, I would take the first outcome, 1, times the probability of the first outcome, plus the second outcome times the probability of the second outcome, all the way up to the 6th outcome times the probability of the 6th outcome. And if you work this out, you'll get 3.5, which is in fact the average of the 6 values that can be obtained by the dice. All right, so here's a formula for expected value of a random variable in terms of the values that the variable can take. In this case, we're looking at discrete random variables. Discrete means that we can list the possible values of x in this way as discrete values. Now if you have a continuous random variable, you cannot do this. Instead of writing a sum, you have to write an integral, but the principle is the same. In this video, we'll focus on discrete random variables because the intuition is much more clear, and the idea is similar in the case of continuous random variables. Now given these definitions, we have key formula 2, which is the formula for conditional expectation. The expected value for a variable x is equal to the conditional expectation of x given event A1 times the probability of A1 plus the conditional expectation of x given event A2 times the probability of A2 plus plus the conditional expectation of x given the event AN times the probability of AN. Now key formula 2 expresses the expected value of x in terms of conditional expectations. You can see that the expected value of x is a sum of terms. Each term has the expected value of x given a particular event times the probability of that event. You can see that the formula is extremely similar to key formula 1, except in key formula 1 we had p of x here, and we had p of x given A1, p of x given A2, up to p of x given AN. So all we're doing is replacing the p's with e's. Now what does e of x given ak mean? That's the expectation of x within the set ak. In other words, it's the expected value of x restricting the sample space to the set ak. The formula for x given ak is as follows. The expectation of x given ak is the sum from k equals 1 to k of the values of xk times the probability that x takes that value, but you're restricting the probability to the event ak. Notice that this formula is in fact quite similar to this formula. I could write this formula in summation notation as follows. The sum from k equals 1 to k of the expected value of x given ak times the probability of ak. Right. So you can see that this formula is quite similar to the formula below. Right. Now, it's straightforward to prove formula 2 from formula 1 using the following steps. First, we define an event associated with each value of the random variable x. Specifically, we define the event bk to be equal to the event that x equals xk. Remember the difference. Random variables take values. Events are either true or false. If x takes that value xk, then bk is true. If x does not take the value xk, then bk is not true. Second step, write down the first key formula for conditional probabilities using these different events that you defined in part A. Step C, you multiply the kth formula you obtained in part B by x sub k. So you're multiplying the formula by the value associated with that event. Then finally you sum all of these equations together, and you should obtain this key formula too. So your exercise is to write out these steps A through D listed here to prove key formula 2. All right, so let's look at an example. Let's consider a set of students divided into 3 classes with different marks on their quizzes. All right, so here's our sample space. Sample space is the space of all students. And we're divided into 3 classes. I'll just divide them like this. I can call this class 1, class 2, class 3. And let's say the different marks are as follows. This person got a 92 out of 100. This person got 84. And this person got a 66. This person got a 43, and this person got a 95. And this person got a 27. This person got 100. Okay. Now, so I have altogether 1, 2, 3, 4, 5, 6, 7 students, and I want to find the expected mark of a randomly chosen student. I should say expected mark here. So how do I compute this? Well, recall the conditional expectation formula. I can write it in the margin here. The expected value, and I'll call the mark of a randomly chosen student, I'll call that x. It's equal to the summation. In this case, we're going to sum from k equals 1 to 3 of the expected value of x given ck times the probability of ck. Okay, so how would we do this? The first class, what's the expected mark of the student in class 1? Well, if we use the conditional probability formula, we get 92% or 0.92 times the probability of 92, that's 1 out of 3. Then we get 0.84 times 1 out of 3. And then we get 0.66 times 1 out of 3. And the result is close to 0.81. I'm rounding to 2 digits. Similarly, I can compute the expectation of x given xc2. That's equal to 0.43. Now in C2, there's only 2 students. So if I restrict my sample space to C2, the probability of 0.43 is 1/2. The second mark is 0.95. And here I have times 1/2. So if I take the average of these two, I get 0.69. Then finally, I take the expectation of x given C3. So we can write this very easily. This is just 0.27 times 1/2 plus 1 times 1/2. And you can work this out. Is 0.635. So finally, to get the expectation of x, I can write this as my first expectation, 0.81, times the probability of the first class. The probability of the first class is 3 out of 7, plus the second conditional expectation, which is 0.69, times the probability of the second class, plus the third conditional expectation, which is 0.635, times the probability of the third class. And you can get this result. Now you could compare the expected value directly. And you can do this as an exercise. The direct calculation would be the expected value of x is equal to the sum from n equals 1 to n of xn, probability that x equals xn. All right, so you can compare that this sum with conditional expectations gives me the same sum if I directly compute the expected value. So we have another exercise here to emphasize this concept. In China, families can only have 0, 1, or 2 children. Given the following statistics, in Guangdong province with 50 million families, there are 5%, 35%, and 60% of families have 0, 1, and 2 children respectively. In other words, 5% have 0 children, 35% have 1 child, and 60% have 2 children. In Jiangsu province, with 25 million families, there are 10%, 60%, and 30% of families having 0, 1, or 2 children respectively. In Shandong province, with 40 million families, there are 10%, 15%, and 75% of families have 0, 1, and 2 children respectively. I hope you know that percentages are associated with probabilities. A percentage of 5% means a probability of 0.05. So, choose a family at random from one of these 3 provinces where the probability of choosing any family is the same regardless of what province he or she is from. Find the expected number of children in the family you have chosen. All right? So that's our final exercise. Thank you for watching.